to the browser. So let's get this. Where is it here? All right. Yeah, you can hear me. So, okay, good, ladies and gentlemen. So over in the browser, where are we at? Browser, here we go. Let's look for your class here. I'm going to look for the following here. Let's look for some notes, Statistics Online Transition. So there's a couple of notes I want to bring out to you guys. We're going to look at today the Poisson probability distribution, Poisson here. Okay, so I'm going to put that in the comments section. Okay, Poisson, and I'm going to start to describe what the Poisson distribution actually is. Okay, so we work with the binomial distribution, and we use the TI. Is that true? So today we're going to look at what's called the Poisson probability distribution, where your random variable x measures the number. So here's what we're going to say. Let x be the number of arrivals in an interval. Okay, so what x does is the following. X counts arrivals, things that show up. And this is going to be the second part of the phrase that's important. So I'm going to highlight two things. I'm going to say, okay, we're counting arrivals in an interval. And that's going to be an important detail. So things arrive, people arrive, a lot of different things we can think of as arrivals here. I'm going to give you another parameter now just to let you guys know how to look at this and how to think of this. Mu is the average number of arrivals in an interval. And you want that really to be the same interval, by the way. Okay? So I'm not sure. Let's use pink, pretty in pink, where mu is the average or mean number of arrivals in really the same interval. Okay, so there's some ideas going on here. Okay, so we're going to count arrivals in an interval, and then we're always given an average or mean number of arrivals in an interval. Remember, the mean is a summary, right? So the mean or the average. Okay, so for example, we can say the following, right? This is my favorite example, the office hour example. Okay. Students can what? Show up in an office hour. Okay. So we can count students showing up. So X is the number of student visitors. In an office what? Hour. The interval, ladies and gentlemen, is an office hour. Okay? And what you're counting in this case is students arriving. Okay, you guys okay with that? You guys welcome back, by the way. Hope you guys enjoyed your break. But it's time to get back to work. As you guys can see, I'm already in that work mode. So anyway, counting arrivals, showing up, you can think of that as arrivals in an office hour. Students show up, ladies and gentlemen. All right, that's an example. Believe it or not, you know what else can show up? We can be sitting here, and I hope it doesn't happen. So I'm going to knock on wood. Earthquakes. Now say the big one. Do you guys know what the big one is by any chance? What's the big one? Yeah, we got to be, believe it or not, people are too vague in their communication at times, right? The big one, I think it has a definition. It's going to be an earthquake. We can sit here and believe it or not, we can experience an earthquake. An earthquake can arrive. That's thought of as an arrival. We could be sitting here and a hurricane can arrive. Earthquakes can arrive, hurricanes can arrive, tornadoes can arrive, okay? The tile in the ceiling can drop and hit you on the head. We can think of the tile arriving. Students can show up in the room, that's arriving. So there's a lot of things that we can think of that can arrive arbitrarily, So earthquakes, for an example. An earthquake, and I'm not sure the definition, above 6.0 on the Richter scale. On the southern section of the San Andreas Fault. So earthquakes can be thought of as arrivals, and you say, "What do we mean?" Well, I'm going to say let X be, and here's what I'm going to say here: an earthquake above 6.0 on the center. Well, X is going to count. We'll say the number of what? Big ones, and they might have to give you an interval here. So we'll say the following here, okay? Earthquakes, big ones. An earthquake above 6.0 on the southern section of the San Andreas Fault in the next 5 years. So they need to give you an interval, okay? That's the interval I just gave you. So all you're going to say now is something like this. You can say let X equal the number of big ones, earthquakes, showing up in the next, 5 years. So you guys know. So they need to give you an interval. And they did. What they also have to give you is information. They might say, there is a mean or an average. Let's use the word average. Is 0.2 big ones in a 5-year interval. So they're going to have to give you that kind of information. You want it to be the same interval. So they're going to need to give you, we'll put that in pink, an average of 0.2 big ones. So in this example, mu will equal 0.2 big ones. And of course, it's in a 5-year interval. So over here, they didn't give you one. Let's do that now. In office hour, they may say something like this. Snodgrass, that's the professor, has about 4 student visitors in every office hour. Okay, so let me see. Let's kind of move this out of the way. Let's create some space so I can give you guys all the relevant information. Okay. So here mu is equal to 4, and that's in an 4, that's the average. Okay, so I want you guys to understand one important thing here. We represent the average with that letter mu. Okay, that's the mean, or that's the average. Mu. Does anybody happen to know anything about that letter? What's mu? What's an average, right? Mu is a Greek letter. It's a capital. I'm sorry, it's not capital. It might be lowercase. Mu is a Greek letter. And I used to have that picture here. So I'm going to look for it. Okay, images. Yes. Mu. Let me see if I can do this here. Oh, they're gonna charge me for it? I don't want to get charged for mu. Share with you guys mu. Get that, the Greek letter mu. It's a Greek letter. Let's try to find a nice mu. I used to have one whenever I talked about this. There we go. Yeah, I don't know if it's is it like the Greek letter M, mu? It's a lowercase letter. Yeah, it looks like it's an M. See that symbol? It's the Greek letter mu, ladies and gentlemen. Mu. It means mean. Okay, it's mean. It's the average. What's an average? Isn't that a summary? So I'm kind of, man, I want that mu. Darn. I guess I can't do it because of the color. Anyway. Anyway, mu, 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 mu. Oh, here's a gold mu. Okay, fine. Whatever. So, mu. Big ones. So, here's what I want you guys to know, what you'll be working with. This is the Poisson probability distribution. We work with a binomial. So now this is a Poisson probability distribution. Okay? And in my notes, by the way, if I go back, nope, that's not you guys. This is you guys. here's the deal, right? X is the number of arrivals in an interval. Mu is the average number of arrivals in the interval. And then this is the formula. This is the formula we used to use back before to the TI days. Okay. And this is my favorite example here. Office hour visits. So let's do this here. Let's go do something here. I'm going to go back to go to my website, 227. And you guys can't see this, but I'm going to try to log in. I'm not connected to the Wi-Fi. Okay. It says I'm connected now. I have to put all my information. Okay, so we're going to look at this example here using the Poisson distribution, but I'm going to enter this in the TI. Okay, so write this down, ladies and gentlemen, this office hour example. Professor Snodgrass typically has 4 students visit in an office hour. That's the average. Okay. And I'm going to get this here. All right, let's go over this now. And there's our mu. Look at that, mu for average. Okay, so when we talk about, this is our mean. I'm going to put that in pink. 4 students visit in a what? Office hour. How long is it? What's the interval for an office hour? 60 minutes. Is that true? So what they're saying to you guys is mu is equal to 4 student visitors in a 60-minute interval. That's our mu. It looks like a U with a long tooth. Okay? That's the average. They're giving us typically what we experience, the average. And then they want to know, look at the question. What is the probability, question 1, no students visit? Now remember, X counts visitors. So X is the number of student visitors in an office hour. And that's going to be in the office hour, because they say in the next office hour. So X is the number of visitors in an office hour. And when they say no students visit, what's the value of X? That means X is 0. Good. Okay. 1 student visits. What's the value of X here? 2 students visit. What's X? 2. 3 students visit. What's X? 3. 4 students. X is 4. So ladies and gentlemen, again, let X be what's in the question. Okay? So that you guys can start to see that when they say like the word no, that means X is 0, right? When they say 1, 2, 3, 4. That's where you get x is 0, 1, 2, 3, and 4. And that's what I'm saying here. Now, what we're going to use today is not the formula. This is the real formula. We're going to use what? The TI. And what does the TI say, right? What do we use? We're going to go look at the what again? We're going to look at the distribution list. And we're going to look for Poisson PDF. What did we look for before spring break? Binomial probability distribution function. Now we're looking at Poisson. We're counting arrivals in an interval where we're given a typical number of arrivals. You only need two numbers, ladies and gentlemen. We need the value what? Mu, the mean, and we need the value of x. If you have those two, and I think we put that in gray, then we could use the what? The Poisson. Because the Poisson requires only two numbers, mu and what's the other one? X. Mu and x. In this case, mu was what? 4. That's the average. What's x? 0. No arrivals. We're just counting arrivals. That's like nice whole numbers. 0, 1, 2, 3. How many students arrived today in class? If I ask you guys, you just have to count. How many students arrived? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 20 students arrived today in class. 22 students arrived. I counted. How many online? Can you guys see? 9. How many arrivals do we have? 22 plus 9 is what? We have 31 arrivals. You guys okay with that? Counting students arriving. Well, we're looking at an office hour. How many? Has anybody ever visited an instructor during an office hour? Right? How many of you guys have seen an instructor during an office hour? Raise your hand. Just curious. Okay. How many people never went to an office hour for an instructor? Never. Okay. There are some. There are some. So what do you think Mr. Judge does in an office hour? He what? He sits and he waits for students. Isn't that interesting? He sits, he waits for students. Sometimes while he's waiting, what does he do? He has lunch or breakfast as he's waiting. Sometimes he's working as he's waiting for students. In fact, most of the time he's working. Boring. Who wants to work all the time? I think I'm done working. I just have to pray that I win the lottery. Oh my God, let's win the lottery so I don't have to work anymore. But that would probably be boring. Would that be boring if you didn't work? No? What would you do all day if you didn't work? Sleep? Exercise? Good. It's better than sleep. What else would you guys do? You go hiking? Where are the hikers in the room? Oh, have you ever heard of backpacking? Mr. Judge is a backpacker. You ever been in the Yosemite wilderness backpacking? Then you haven't lived. You're not alive. I feel sorry for you. You got to get out there and see some, but be careful. You better know what you're doing. You better do your homework. Because if you ever go in the wilderness, you better be careful, ladies and gentlemen. Because people don't come back from the wilderness. It's easy to see why it happens. So, but there's some beautiful places you guys can see. You haven't seen beauty yet. If you haven't done that kind of stuff, you haven't seen anything beautiful. I feel bad for people. You haven't seen anything beautiful. Get out to Yosemite wilderness, then you can see some beauty, ladies and gentlemen. Anyway, so maybe that's what I do during my office hours, just daydream about the wilderness as I'm waiting for students to show up. Yeah, that'd be a good thing. Imagine. Oh, I could do that. Maybe I do want to win the lottery and just go backpacking. Travel to other countries and backpack. That might be scary. Because you don't know what's out there. Other countries may have different kinds of snakes. They may not be rattlesnakes like in California. Are there snakes out there in the wilderness? Do you guys know? I've seen them. What else is in the wilderness? Huh? Wolves? Yeah, I haven't seen coyotes though, but I've seen bears, deer, deer and bears. What else have I seen? Rattlesnakes. Huh? Haven't seen Bigfoot, but I hear he's out there or she's out there. Bigfoot. Anybody here believe in Bigfoot? Anybody see Bigfoot? No, if you guys don't go out in the wilderness, you don't probably know about Bigfoot. No? I'll tell you one thing, it's pretty interesting. When you go out to the wilderness and you're out there and you're sleeping at night, I don't know, it's kind of crazy. It's really loud. It can be loud out there. You go, what are you talking about? It's the middle of the night. There's a lot of creatures that are nocturnal, meaning they come alive at night. You can even hear them. It's crazy. You're like, how come it's so noisy? Nocturnal creatures. Well, why don't I hear it out in the city? Well, you hear other things in the city. You hear cars and people arguing and dogs barking. Do you guys live in that neighborhood? The dog barks all the time? And you get mad and you're kind of like, what the hell? Why don't they just shut that dog up? And they don't. Do you guys know what I mean? Dogs barking. Like, oh my gosh. Well, in the wilderness, you do hear other things out there. It's kind of interesting. Anyway, I digress. Now that you guys are awake. Count your arrivals. That is X. What is mu? The average number of arrivals. So in this first example, we're going to try to find P of what? If X is 0, we want to approximate P of 0. Let me show you guys how easy the Poisson is. Yep. And it's a French name. It sounds like Poisson. Sounds like poison. Students always used to say, is that the Poisson distribution? And I'd say, no, it's Poisson. It's Poisson. It's pronounced Poisson. French. Let's clear this out. We're going to get to the distribution list. We got to go here, right? It's blue. Do you guys remember how do you get to distributions? It's that blue, so you have to hit the second list. You have to hit the blue second and vars. Now we're in the distributions. Which do we look for? Poisson. It means fish. It's a name, but it's fish. Here we go. It's D, the Poisson probability distribution formula. What do I enter? What was mu in this example? How many arrivals typically show up? Good. 4. Easy breezy. What was X if nobody shows up? 0. Is that true? Paste that in, ladies and gentlemen. There you go. And that's it. Go out to the nearest thousands. This is the probability that nobody will visit. It's a probability. 0.018. Okay? And what does that even mean? That's like 1.8% chance. So there's a 1.8% chance that no one will show up for Snodgrass's office hours, ladies and gentlemen. Okay? Easy breezy? So that's like me sitting around. I typically have 4 students visit, and you know what? Nobody showed. What's the chance of that? It's about a 1.8% chance of no one showing up. It's counting arrivals. Anything can arrive. What do you guys think? Is that easy? It's only 2 numbers you have to remember. So what about the next question here? They want to know what P of 2 is. I'm sorry, P of 1. Sorry. What's the probability one student visits? Well, that's P of 1. Okay, don't use the formula. Use the TI. Now, again, I'm going to scroll out a little bit. Okay, so we're going to do this again. We're going to say now, go to the distribution list. It's right here. It's in blue. Distribution. Go all the way down to D. That's where Poisson is. Right? Poisson. Fish. Now change not mu, change X to what? 1. This is P of 1. Paste that in. Ladies and gentlemen, this is point what? 0.73 to the nearest thousands. All right. And what does that give you? That's what? That's 7.3%. So there's a 7.3% chance one student will visit. What do you guys think? Is that pretty easy? I don't know about you guys. I think that's pretty simple. What's the next question? What's the probability that what? 2 students visit. They want to know P of 2. The chance of 2 student visitors? Yes. Okay, TI. Second distribution. Poisson PDF. What's your X value now? 2. Paste that in. Mu is still 4. It's still the same setting. And you get now what? 0.1. Let's go to nearest thousands. 0.14. What is that? Is that 6 or 7? 7, ladies and gentlemen. And that corresponds to saying that there's a 14.7% chance that 2 students will visit in the next office hour when typically 4. So I wrote this, set of notes for you guys. Okay. 3 students visit. Oh, X is 3. We want to find P of 3. So, I'm showing you guys here how to do this on the TI. Second distribution, binomial, go all the way down. Poisson. X is what? 3, and you paste that in now. So what's that chance? 0.19 what? 5, okay? So what is that as a percent, by the way? It's 19.5%. Is that right? So there's a 19.5% chance that 3 students will show up when the average or the typical is 4 students. What do you guys think? Is that pretty simple? Imagine the old days where you had to use that formula. This is the chance that what? 4 students visit. They want to know what P of 4 is. We're counting student visitors. Okay, go to the TI. Change your X value to what now? Second distribution, change it to 4. The X value, oops. What's that probability? Looks like it's also 0.195. Is that right? Okay. Again, there's a 19 point what? 5% chance a student will show up, a student will visit. And of course, what did I write in your notes? What are my favorite questions of all time, ladies and gentlemen? What are my favorite questions? What's the probability at least one student visits? What's the meaning of at least one? Remember, X counts student visitors. That's X greater than or equal to what? 1. Isn't that one or more? Didn't we look at that before the break? Aren't you guys glad you're back? Anybody play their Xbox during the break? What about the PlayStation? How come you guys like PlayStation over Xbox? It's free? Huh? You do what? Oh, you charge it instead of using batteries? Mm. Mm. I'm just trying to figure out what should I get? Should I get a PlayStation 5 or Xbox One, whatever? PlayStation? PC? PC's better than both of those? Really? Why are PCs better? Oh, make my own computer? I use Mac though. Can't make a Mac. Can you? Can I play like the PlayStation on my Mac? I don't know. I don't know. I was just thinking. That's what I was thinking of during my break because I get some relatives coming in with some kids. You know what I mean? And they're like bored, so I'll just go get them a PlayStation. And then I found out I had to wait a whole week to get one. So okay. Same thing with the Xbox. Xbox One. I don't know what it is. One something. Mm-hmm. Huh? Anyway, those poor kids. Huh? So you guys think a PC's better, huh? You guys sound like PC's better. Mm-hmm. I don't know why a PC would be better. There's more games on a PC? Oh, you don't pay for the online subscription either? What if it's just Call of Duty? I don't know. I don't know. X greater than 3. I think I'll stick to Poisson. What do you guys think? Is that more than 3? How to describe no more than 4? X is less than or equal to 4. Between 2 and 5. Yeah, I don't know what to do. I don't even have time to play anyway, so what's the deal? So what I'm going to do here, ladies and gentlemen, I'm going to give you guys time to answer these questions here. Okay? And see what you guys get as I try to think about Okay. The at least one question. What do you guys remember about this? You guys remember anything about at least one? How do we handle at least one? Guess I have to write it again. Yes. What am I getting at? Right, number 6. Remember the definition. At least one is 1 or what? Or 2 or 3 or 4 or 5. That goes on forever. Is that true? Now, this is by definition. What do we say you guys want to use here? Yes. 1 minus the probability of the outcomes that are not here. So what's not here for at least 1? You got 1 or 2 or 3 or 4. What's not here is 0. So use the complement rule, ladies and gentlemen. And it could be that simple in the sense that, here's what I mean. You can put 1 minus, this is going to be P of 0, distribution list. Okay, change the X value to what now? 0. Paste that in. So what you're looking at is 1 minus P of 0, the same way you see it here. This is the complement rule. Okay, you guys okay with that? You can put it all in your TI and then hit enter, and there's your answer. So go out to the nearest thousands here. So by the complement rule, that's 0.98 what? 2. So what that means is there's a 98.2% chance that at least one student will show up. What does at least one mean? 1 or what? Or more. Good. What's at least 2? P of 2 plus P of 3 forever. 2 or 3 or 4 and so on. You guys remember? But by the complement rule, 1 minus P of 0 minus P of 1, because the 2 outcomes that are not here in the definition, the meaning of at least 2 is 2 or 3 or 4 or 5 or 6. So I can do this all in the TI now. One minus second distribution. We already have P of 0 here. Okay. Now minus P of 1. So this would be second distribution. There we go, Poisson, PDF. Change this X value to 1 now. Paste it in. And what do you get? 0.90 what? 8. And what does that mean? So there's a 90.8% chance at least 2 students will show. Okay, what was the next example? Number 8. Anybody remember? More than 3 for number 8. More than 3, so that's X greater than 3. Is that right? Okay. So what does greater than 3 mean? 4, what else? 5 and 6 forever by definition. But by the complement rule, what do we have to do? It's 1 minus the probability of the outcomes that are not here. So what's not here is P of 0, right? What's not here is P of 1, P of 2, P of 3. So don't use the definition because you would die because you have P of 6, P of 7, P of 8. You'd have to add all those, right? So use the what? Complement rule. 1 minus second distribution. I'm gonna do this systemically, meaning put P of 0. Second distribution. P of 1. Second distribution, P of 2. Second distribution, P of 3. So did I do P of 1, P of 2, P of 3, P of 0? I think I did. Is that right? Okay, what is this going to give you? 0.55 what? Or 5.6. Is it 5.66 or 5.67? It looks like 5.67. Okay. Anyway, so that's a 56.7% chance that at more than 3 students will show up. All right, pretty good. What about P of 9? What was P of 9? I'm sorry, not P of 9, number 9. 9 was, no more than 4. That's 4 or less. So the definition of no more than 4, you take P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4. Okay, so this is no more than 4, 4 or less. 0, 1, 2, 3, 4. 4 or less means you include 4. Are you going to use the complement rule here? Say no. Why can't you use the complement rule? Anybody know? You say, why won't the complement rule work here? Well, what would the complement rule be? Right? The reason you can't use the complement rule is because, by definition, it's 1 minus the probabilities that are not here. What's not here is 5, 6, 7, 8, and forever. So that would be impossible to do because you would die before you finished. Because I got minus P of 8, minus P of 9, minus P of 10, and so on. So you don't use the complement rule, ladies and gentlemen. You use the definition. So I have to take P of 0, P of 1, P of 2, P of 3. I have to add that with P of 4 because that's the meaning of no more than 4. So, okay, let's try this out. Second distribution, P of 0 for Poisson. Plus second distribution, that's going to be P of 1. Now do P of 2. now P of 3. Just add those. P of 0, P of 1, P of 2, P of 3. And then P of 4. Let's go to binomial. I'm sorry, not binomial. Poisson. Poisson. Counting arrivals. And there we go, ladies and gentlemen. What does this equal? 0.6 to 8 or 9? 9. (62.9% chance). Between 2 and 5. Between 2 and 5 now. So P of 2, P of 3, P of 4, and P of 5. So these are all the arrivals 2, 3, 4, and 5. So all in the TI. Second distribution, we're going to put P of 2 all the way up to P of 5. Okay, now P of 4. Okay, hit the last one there. Now X is 5. You're just changing all the X values. The mean is 4 in every case. So now we have that sum, and that's going to be, what is this going to be? 0.69. Is that a 3 or a 4? It's going to become a 4. It's a 3, but the digit to the right is a 5. So what this means now is there's the probability in blue, but the language portion is 69.4%. So, ladies and gentlemen, 69.4% of the time, Snodgrass, there's a chance that there's between 2 and 5 visitors. Okay, so what I'm sharing with you guys here today is introducing to you what we call what is this called again? The Poisson probability distribution. What does it count? Counts arrivals in an interval. And what is mu? It's the average number of arrivals, the mean number of arrivals, the typical, or the summary of the arrivals in an interval. So very simply, this is how you really fundamentally just simply apply the Poisson distribution. Now, tomorrow, I'm going to work on the phrase called interval because they're going to change the interval on you. What if they say in the next 25 minutes of an office hour, not in the next office hour? What if they change the interval? We're going to see how proportions work. Okay, so ladies and gentlemen, I hope you guys enjoyed the lecture today. Welcome back. And this is better than an Xbox. Or it's better than what? PlayStation. Better than a PC. All right, you guys, take care. Have a great day. All right. Okay, ladies and gentlemen, good morning, good afternoon, whatever this is. So here's the thing. All right. What did we work on last time? Do you guys remember? We worked on these things called what? Intervals. Is that true? So this was actually in relation to the Poisson distribution. Working with intervals is in relation to the Poisson. So do you remember we did this kind of example? So we're going to go back to Poisson and we're going to talk about this. We're going to go, okay, in an office hour, 4 students visit in an office hour. So, okay, let me try to copy this all now. And we're going to transition to the interval situation in an office hour now, right? So, okay. So, for example, students show up. Let me erase some of this here. All right, Snodgrass shows up in a typical office hour. And I'm going to put this comma on average. Okay, so yes, mu is 4 in a what time interval? In an hour interval. Is that true? Because that's what they're saying. So we're going back to the Poisson, ladies and gentlemen. We're counting arrivals in Poisson. We're going to use the information we worked on last time to finish this up. So Snodgrass has 4 student visitors in every office hour, and that's on average. Now here's what's going to happen. In the next what? 22 minutes now, of course, of an office hour. What's the probability at most? I'll just say this. No more than 2 students show. No more than 2 students visit. Office what? Hour. Okay? So this is focusing on that idea for Poisson that this has to be in the right interval, right? So now what do they just change on you guys? This is a probability question. You say, what do you mean? Because they're saying, what's the probability? But now, what's the language? No more than 2 students visit. So no more than 2 is x is less than or equal to 2. So here's your probability question in terms of the notation. Okay, you guys good with that? Is that right? If you guys read this here, probability no more than 2 students visit, since x is going to be the number of what? X counts arrivals. X is the number of student visitors. But it's student visitors in what time interval? In the 22-minute interval. So what that means, ladies and gentlemen, is that they just changed on you what? The interval. They say 4 visits in a what? In an hour. So this is 4 visits per what? 60 minutes better equal what? Mu visits in 22 what? Minutes. So the idea is that you have to get the new what? Mu, because the new mu is in a 22-minute interval. So it's no longer 4 visits, which are in an hour, 60 minutes. You need to find how many visits are in 22 minutes. So this is where you're going to now do what? You create the proportion. This is why you guys had that homework. You create the proportion. And now what is your mu going to be, right? You solve for mu, right? Isn't that going to be, let's do cross multiplication. That's now 4 times 22 will be what? 60 times mu. So you can divide both sides now by that 60, where now mu becomes what? 4 times 22 divided by 60. So what's your new average going to be here for that mu? So here's the deal. 4 times 22 times what? 60. Oops, clear. 4 times 22 divided by what? 60. So this is 4 point, let's go out to the nearest thousands. 4, 6, what? 7. Okay? 1.467. So what did you guys just find? You guys just found the what? The number of students visit and what time interval? This is visits per what? That 22-minute interval. The point is, this is your new mu. That's your new mu. There it is, ladies and gentlemen. There it is. So the whole reason you guys worked on those ratios and proportions last week is so you can answer questions where they change the time interval on you. This is now in 22 minutes of an hour, not in the whole hour. So remember what the meaning of no more than 2 is. That's 0, that's 1, and that's what? 2. So what do you guys use in the TI? Do you guys remember? What distribution? What formula? What do we use? You guys remember? You guys use what? Poisson PDF. So you're back to the Poisson. And how do you get there, if you guys remember? All right, what do you guys do? Remember, you have to go where to what? Second distribution. That's where the distribution list is. You're not looking for binomial. This is a Poisson distribution. So you go to, where do you go to? Where is it? There you go. Is it D, Poisson PDF? But what's your mu now? 1 point what? 467. What's your first value of x? That's 0. You're going to paste that in, ladies and gentlemen. So you're looking at here, this is the P of 0 you did. You have to add P of 1 and P of 2. So you're going to the Poisson distribution again. Now we got to do P of 1 now. So you say second distribution, go down to Poisson. X is what? 1. Paste that. Now X is what number? 2. Paste that in. Here you go. And what do you guys get? Let's go to the nearest thousands. What is this approximately? Anyone know? This is going to be point what? 3 what? 0.326. And there you go, ladies and gentlemen. P of 0 plus P of 1 plus P of 2, 0.326. But that's why we went through changing the interval on you last time. That's why we went through all that kind of homework. Did you guys work on your homework? Good. That's why you did it. So let's compare and contrast, right? Note again, we're going to go back to the drawing board here. Note, they gave you 4 visits, right, per what? Hour. So we wrote that down as 4 to 60 minutes. That was the original rate they talk about. Now, they say, in the next, 45 minutes, they change their interval now. They change it again. What's the probability at least one student visits? So they changed it on you again. You say, what did they change it to? What's your time interval now? It's no longer per hour. It's now per what? It's in the next what? 45 minutes. So what do you guys think you now have to do? Find the mu visits in what? In 45 what? Minutes. Whew. All right, you guys okay with that? That's what you have to do. Mu visits per 45 minutes. So they change the interval on you. And now again, you have to do some what? Cross multiply to get your new mu. This is how it works. So now you go, okay. Say, is that going to be what? 4 times 45 becomes what? 60 times mu. And then divide both sides now by your 60. Mu is going to be what? Isn't that 4 times 45 over 60? Let's see what your new mu is going to be. Four times 45 divided by what? 60. Mu is going to now be what? 3. So remember, this is the mu you use in what time interval? In a 45-minute time interval. So that's going to change. But what kind of probability question is this? What's the language? At least one. How do you handle at least one? Right? This is the probability that x is greater than or equal to 1. So by definition, P of 1 plus P of 2, and then that goes on forever, P of 3, P of 4, P of 5. Is that right? Do you guys want to use the definition? I say no. What should you use? Well, I use the complement rule. Well, you see over here, you have to say P of 1, P of 2, P of 3. That means it goes on forever. So you would die before you finish the question. Because you got P of 10 there, P of 20, P of 100. That goes forever. So 1 minus the probability of what is not here, that's P of 0. That's the easiest to use. That's like one of the easiest questions, at least one, if you use the complement rule, right? So in your calculator now, you say, okay, 1 minus what distribution again? Poisson. What's your mu now in 45 minutes, though? What's mu? 3. And then you have to say, oh, not change x to what? 0. Paste that in. 1 minus P of 0, what does that give you? That's point what? 0 point what? 95 what? 0. So there's a 95% chance at least one student will what? Visit. 45 minutes. 95% chance. At least one student visits. Easy peasy, lemon squeezy. And that's in a 45-minute what? Time interval. Okay, you guys okay with that? All right. Now, anybody have any questions on the Poisson distribution? Let me say this to you guys. Here's an example of a murder rate question again, right? We're going to make up a city. How about we just say Springfield? What happens in Springfield? Do you guys know? You guys know what I mean? Springfield? Is it Springfield, Illinois? I don't know. Where is it? Massachusetts? Okay. Springfield has, what? 450 murders per year. In the next, what? In the next what? In the next week, comma, what's the probability of more than 2 murders? So I'm going to give you guys some time to do this Poisson distribution, okay? So good morning, Christina. Good morning to you. Good morning, Brittany, right? Good morning, Frank. Those are the people that are at home today, even though there's 8 people. Okay, so let's ask you guys this question here. Springfield has 450 murders per year. Now, how many days are in a year? Be careful here, okay? Sometimes they'll give you clarification and say it's a non-leap year. So non-leap year. So what does that mean to have a non-leap year? 365 days. What about a leap year? How many days? What's the difference? Do you guys know? We have leap years and non-leap years. So how many days are in a leap year? Oh, where's my sound effects? Days in a leap year. How many? Do you guys know? 366 days in a leap year. You got February 29th. In a non-leap year, you only go up to February 28th. So just to let you guys know. Okay? So in other words, I'm going to give you guys some time here. And let's see what you get. All right? Let's see. Lucky number 8. Give you guys some of that time. Okay, ladies and gentlemen, let's take a look at this here. Okay, so, all right, now, okay. So what is happening here? Do you guys know? Right? Our topic is the Poisson distribution, and we're changing the interval on you. What is X counting, right? X is counting arrivals in an interval. So what is actually arriving in this question here? Do you guys know? We're counting arrivals. These are the number of murders. So like you're thinking, for example, that dead bodies show up throughout the city of Springfield. I know it sounds horrible, but that's a Poisson distribution. You're counting arrivals. So murders are popping up everywhere. Now, what did they give you, though? Because they ask you a probability question, but they asked you in what time interval? In a week. Now, I didn't define it for you guys, but this is murders in a week. What do I mean by a week? What's a week? 7 days, okay? Now, on a test, I'm a little bit more specific. I'll put 7 days because, you know, sometimes people don't know what a week is. You guys know what I mean? They might think a week is 5 days. You go, no, that's called a work week, 5 days. However, that's traditionally called a work week. Non-traditionally, you can now define it any day you want, you know what I mean? But anyway, on a test, I'll put 7 days for a week, okay? Just to be clear, because you want to be clear. All right, now what kind of rate did they give you guys? What did they give you? What's the original rate? They gathered data and found there's 450 murders in a year, meaning 365 days, a non-leap year. So the rate is going to be what? 450 out of 365. That's murders. And that's per what? Non-leap year. Okay. Now you set that equal to mu in how many days? 7 days. And I got to change this to days because 365 is days. So remember what I said to you guys the other day. You need to be consistent. So if days are in the bottom, days are in the bottom, right? Okay, you don't want to mix that up. Now this is mu. This is mu murders. You don't know how many. That's what you're finding. So how do we find this out? Do you guys remember? What do you guys do? Cross what? Multiply. So 7 times 450 is 365 times mu. Divide both sides by 365. And what is mu equal, ladies and gentlemen? 7 times 450 out of what? 365. What is your mu going to be now? Okay, this is where your calculator comes in. So double check now. TI, here we go, TI, right? So 7 times 450 divided by what? 365. What do you guys get? What is mu going to be? 8.63 what? 0. So remember, what that mu is, it's telling you that this is the number of murders per what? Per week. If the murder rate is 450 per 365 days, that becomes 8.630 per week. So, and a week being 7 days, okay? So that's in the time interval of a week. So that word interval I've been making a big deal about. That's the deal. Now, that's not your final answer. That's just your mu, because what are they saying? What's the what? Probability of more than what? 2 murders, and that's in that week. So how do you describe more than 2 if X is the number of murders in a week? Isn't that greater than 2? More than 2 is greater than 2. And again, ladies and gentlemen, what's greater than 2? 3 murders. What else? 4 murders. What else? That goes on forever. So now, what do you get? What's this? 1 minus P of 0 minus P of 1 minus P of 2. Why did I do that? Because it's easier to use the complement rule. Because by definition, more than 2 includes what? 3, 4, 5, 6, 7, 8, 9, 10, 11. You would die before you finish. But the complement rule, 1 minus the probability of the outcomes that are not here. What's not here is 0, 1, 2. Now you can punch this in your TI. Right? So what do you guys do? Do you guys have your TI? You might want to get it out. 1 minus, go where? Go to your distribution list. Go down to what? Poisson. Where's that? Right here. D. So change this mu now to 8.630. X is 0 minus second distribution. Go to Poisson again. What's your new value of X? 1. Okay, down there. Now paste that in. Okay, good. Now what's the new value of X? Second distribution. What's the new value? Just change that now to X is 2. Where do you guys stop? What value of X do you guys stop here? At 2? Okay. So you go back and you go, oh yeah, we're using the complement rule. 1 minus P of 0 minus P of 1 minus P of 2. Okay. All right. Hit what? Enter. And what does this give you guys? What's this going to be? 0.99 what? 2. 0.992. So in other words, you have a 99 point what? 2% chance, which is greater than 95% chance that you will have what? More than 2 murders in the next what? Week. In the next week. More than 2 murders in the next week, ladies and gentlemen. So what does that mean? It is almost what? Almost certain you will have more than 2 murders in the next what? Week. Okay, do you guys see how we use this here? You see how we kick that up? That change? Okay, and then let's say to you guys, what about in the what? The next 10-day interval. 10 days. What's the probability there's no more than 2 murders? Okay, so what did they do now with this question here? This is now in the next what? In the next 10 days. Is that right? So they changed your interval on you. Probability, no more than 2. How do you describe no more than 2? X is less than or equal to 2. Is that true? It's 2 or less. 2 or less. So now we say, do we need P of 0 plus P of 1 plus P of 2? We do. And go back over here. What is mu again? Remember this original rate? Right? Let me copy all of it. Let's see if you guys can understand. What's the difference between the question we just did, the question we're about to do? How many days now? 10 days. So what do you guys do now with this? 10 times 450 is 365 times mu. Isn't this what you get by cross multiplication, right? So now you divide both sides by what? 365. So what's your new mu now in a 10-day interval, right? 10 times 450 over 365. This is your new mu. So mu becomes the following. Let's see. 10 times 450 divided by 365. 12 point what? 3, 2, what? 9. P of 0, P of 1, P of 2, 12.329. So go to the TI now. Second distribution. What's your mu? 12 point what? 329. What's your first value of x? 0. Paste that in. Plus second distribution. X is what value? 1. Paste that in. Plus second distribution. Where's this? X is now what? 2. Paste that in. Uh-oh, something's wrong. Nope, it's not wrong. Let's see what you got. This is a good example, ladies and gentlemen. I'm going to scroll in, okay? So let me figure out how to scroll in. What do you guys notice about this answer? Is there anything special about this answer? Huh? I mean, if you write it down, you say, you know what it is, Mr. Judge? 3.950. Don't forget what you're really looking at. If you tell me that there's a probability that is about 3.950, if you tell me this story here, ladies and gentlemen, what's the problem? That's wrong. Because probabilities are not more than 1. Do you guys remember? They can't be more than 1. There's no way. So what is it that you're really looking at? Don't forget this is e to the negative 4. What is this? That's times. This is scientific notation. Scientific what? Notation, ladies and gentlemen. So by scientific notation, you got 3.950. What are you supposed to do with this decimal place? You're supposed to move it how? What does this negative 4 mean? You move it to the what? You guys see what I'm saying? This is movement to the left. How many units? 1, 2, 3, 4 units. It's here. Then you fill in the zeros here. So what do you now get? This is now the tenths. Let's go back. We're going to round to the nearest thousands. Tenths, 100, thousands here, right? You look at the digit to the right, and it's a 3. What does this mean, ladies and gentlemen? 1, 2, 3. And then that's it. So what are you looking at here? What does that actually mean? This is approximately what number? 0. Does that mean it's equal to 0? Say no. This is approximately 0. This is what you give as an answer. You want to give that as an answer. Okay? That's what you give as an answer. But what does this mean about the event? That's less than 5% because that's actually 0.0%. But that's approximately 0%. That's not equal. If it equals, the event is impossible. It doesn't equal. It's approximately equal. So that means the event is what? Not likely. So you say, what do you mean it's not likely? This event is not likely to happen. It's not likely to happen in the next 10 days that there's no more than 2 murders. Okay? It's still possible. It just isn't what? It's not likely. That's what you use down here. It's not likely to happen. What do you guys think? Easy peasy lemon squeezy? So the whole reason we went through that last time is so you guys can do what? These kind of questions. They change the interval on you. Okay, so let me give you another example. You guys ready? It's another example. We're in Springfield again. Springfield experiences 200 earthquakes. Above 4.0 in a 500-year time interval, according to data that they gathered. Okay? In the next decade, what's the probability of an earthquake? Yeah, I'm going to say this. What's the probability of an earthquake? Of course, above 4.0. Springfield. Now, notice something here. Notice the language. Right? What do they mean? First of all, this is in what time interval? What does a decade mean? 10 years, is that right? That's a decade, 10 years. What's the probability of an earthquake above 4.0? Because X is going to equal what again? X equals the number of earthquakes above 4.0 in a what? Decade, because that's the question, okay? So they're telling you about this information here. Now, when they say an earthquake, what does that mean? What did they just say to you? X equals what number? 1. Good. If I offer you a drink, I'm only offering you what? 1 drink. if I'm offering you an apple, only one apple. So they're asking you, hey, what's exactly one earthquake? Could they have said exactly one? Yes. They didn't. They gave it to you more in casual language. Language you'd use, if somebody came over, would you like a drink? You guys know what I'm saying? They're not trying to be sneaky. They're just trying to be casual. So this is exactly one. Good. Now, what's the deal, though? How do we find mu in a decade? Because notice what they gave you. What did they give you? 200 earthquakes per what? 500 years. So they counted 200 earthquakes, and that's above 4.0 in a 500-year term. That has to equal mu in how many years? How many years, ladies and gentlemen? 10 years. Good. Because that's the question here. So this time, they're just changing what on you? They're changing the interval. Okay? So these questions are Poisson, but they change the interval on you. All right, cross multiply again. Get your mu. Right? What does that mean, ladies and gentlemen? You know what that means? This means what? 10 times 200 is 500 times mu. Divide both sides now by what? 500. Mu is 10 times 200 over what? 500. What is mu going to be? Ten times 200 divided by what? 500. And what do you get? 4. So in this setting, okay, there are 4 earthquakes above 4.0 in a 10-year interval, in a decade. So this is the decade average. They can change mu on you. They can change the interval on you. They can change it. But let's see, in this example, mu is just 4 and x is 1. Is that right? So go back to the Poisson again. Go back to the TI and say, okay, second distribution, Poisson PDF. What is mu? 4. What is x? 1. Paste it in. What's the deal? What do you get now? Right? 0.07 what? 3. And that gives you now what? 7.3%. There's a 7.3% chance in the next decade you will have a earthquake above 4.0. And this is actually how things really work, ladies and gentlemen, when they compute those chances. This is exactly what they do. Okay, they do things this way. And then let's give you a note here. How about this? In the next year, what's the probability there will be between 2 and 4 earthquakes? Above 4.0. Okay. What did they change this interval to? This is now in the next what? Year. Okay. And then you say, well, what are they asking? Well, what are they asking you? This is now a probability question. Between what? 2 and 4. So what's the deal? 2 less than or equal to x less than or equal to 4. P of 2 plus P of 3 plus P of 4. Where's your mu at? What is this ratio again? What do you guys really have to change here? Right? Because now you got to get your mu. These are all your different x values, but what does your mu now become? Right? What changes here? Yeah, it's not in a 10-year. It's now what? 1 year. Do you really have to cross multiply to get your mu? Because this is your new time interval. Right here, it's a 1-year interval. What does that mean? That means mu is really what? 200 earthquakes out of 500. So what does mu become? This is going to be, let's look at that. 200 divided by what? 500. What do you get? And this is not approximate now. This is now what? Equal. So mu equals what? 0.4 earthquakes per what? Per year. Above 4.0. So you're now just going to plug in these x values, P of 2, P of 3, P of 4. Second distribution, we're going to look for Poisson. Mu is 0.4. What is x? 2 plus second distribution. Go back to Poisson. What is x? 3. Same mu. Paste that. Right. Plus, change, not minus, go back. Plus second distribution. Go to Poisson again, ladies and gentlemen. What is your x now going to be here? 4, because this is P of 2 plus P of 3 plus P of 4. Is that right? So what do you get now? What is this? Yeah, this probability is going to be point what? 0.061. Okay. And you say, what does that mean? Oh, move the decimal. That's about a what? That's a 6.1% chance. So it's a 6.1% chance in the next year there'll be between 2 and 4 earthquakes. 6.1% chance. Okay, so do you guys see the point of why we had to do that little worksheet last week? Because you have it today. This is Poisson. What do you guys think? Easy peasy lemon squeezy? Have you guys try one? Okay, let's kind of look here. Bless you. Bless you. Let's look at our browser here now. Let's go back here to kind of share with you guys some of this. So where's this 227? These are some great kind of questions. Statistics library. We're gonna go all the way down to now. Statistics lecture, where? Poisson, where are you, Poisson? Binomial. There you go, like number 11. Look at that. the office hour example, back in 720p days. You know. Search and rescue. Let's do a search and rescue. How about this example? I'm going to make it up, okay? So I'm just looking at search and rescue. Let's say Springfield search and rescue. How's that? Let's stick to Springfield. You guys like Springfield? All right. So I'm going to say Springfield search and rescue experiences for emergency response calls. So I'm going to go to my emergency response. You're going to see what I'm writing down. Calls per, let's say, week. Okay? It's going to do a question that kind of looks like that. So question 1. Let's say in the next week, what's the probability of 2 calls? Question 1. Question 2. And the next. And the next what? In the next month, 30 days, comma, what's the probability of no more than 2 calls? I don't know what that was. What was that? So notice what they gave you here, right? You get 4 emergency response calls, 4 calls per week. Did they tell you what a week was? No, what is a week? 7 days. So we know you get 4 calls per 7 what? Days. Now, what's the interval for question number 1? Do you guys know if we read this? In the next what? Week. So that's in the next 7 days. What do you think that means then? Oh, for question 1, that's my mu, because it's in the same exact interval. 4/7, whatever that is, right? So what does that actually mean, 4/7? Here's my mu. 4 divided by 7. That's the number. That's 0.571. Is that true? So in a week interval, we get about 0.571 emergency response calls. That's the average. So I just want to let you guys know for question 1, the interval is a week. They gave us the rate in a week. Now, what's the question? What's the probability of 2 calls? What does that mean? X equals what? 2. Is that true? Because that means exactly 2 calls when they say 2. Okay, that means exactly 2. Would you guys agree with that? That's not 1, it's 2 now. So we're going to have to find what P of 2 is. All right. Go to your distribution. We're going to Poisson. Today was about Poisson. All right. Change mu to what? What's our mu? 0.571. There's your mu. What's the value of x? 2. And what do you get, ladies and gentlemen? Probability is 0.09 what? 0.092. Is that right? This is the chance of exactly 2 calls. And what is that as a percent? That's going to be what? 9.2%. There's a 9.2% chance that there'll be 2 calls. Question number 2. How does question 1 compare with question 2? Question 2 is saying what now? In the next what? Month. Well, they define a month for us, 30 days. They have to tell us because really a month can have 28 days. It can have 29 days. It can have 30 days. It can have 31 days. Can it have 32? No. All right. So in the next 30 days, now what do you mean? How does that change your mu? Let's copy. How does that change your mu? This is now what? Mu in how many days? This goes down here. We got to have what? They changed the interval to now what? 30 days. We have to cross multiply to get the new mu. So now, here's the deal. 4 times 30 gives you 7 times mu. Divide both sides now by what? 7. What does your mu become? What is mu? 4 times 30 over 7? Four times 30 divided by what? 7. What is mu? 17 point what? 1, 4 what? 3. All right. Let's see what that means. What does that mean? This is now in a month interval. In a month interval, there'll be 17.143 calls. That's the average. That's mu. But what's the question? They want to know what again? What's the what? Probability of what? No more than 2 calls. No more than 2. What's the meaning of no more than 2? X less than or equal to what? 2, because it's 2 or less. Good job. Now, what's the definition? No more than 2, 2 or less, right? What does it mean? It means P of 0, P of 1. Do we include P of 2? Yes, P of 2. Because no more than 2 is 0, 1, or 2. And in this case, mu is 17.143. Because we changed the interval to a month. So in your distribution now, you say, okay, second distribution. Go down to what? Go down to Poisson. 17, right? Point what? 143. What's your x value? 0. Let's paste that in. Change that x to 0. Plus second distribution. What's your x value? Go down to Poisson. We're looking for Poisson. X is now going to be 1. It's the same mu. All right. Now we're going to add that with second distribution. Add that bit with what? What's your x value? 2. Now, let's see if you guys are awake here. Is there a probability value that's 5.924? Don't forget to read all of it. What does all of it actually say? That's e to the minus 6. E to the minus 6. What does that mean? What are you looking at again? What does that mean? This is really times what? 10 to the minus 6. Is that right? And then what does that mean with your decimal? Yeah, left how many spaces? Okay. 1, 2, 3, 4, 5, and what? 6. Fill in that 6 with what? Zeros. Or fill in those spaces with zeros. So again, 1, 2, 3. Look at the digit to the right, because we're going in the thousands position. What's your answer going to be again? Approximately. What is this approximately? That's approximately what? 0. Now, it's approximately 0. It's not actually equal to 0. It's close to 0. Again, 0%, which is less than 5%. What does that actually mean again about the event? This event is not what? It's not likely. It's not likely, ladies and gentlemen, for question 2, that there'll be no more than 2 calls in the next month. It's not likely to happen that there'll be no more than 2. You know, that's what that means for question number 2, not likely. You guys are looking at that probability. Anything smaller than 5% is not likely to happen. And this is Poisson, ladies and gentlemen, and this is about working with what again? That phrase called what? Intervals. This is about intervals here. Easy peasy lemon squeezy? No. That's when they change the intervals on you. So if I go back now, I'm going to go to the browser here again. Where are you, browser? There you are.